Good evening, welcome back. The classification of elements in periodicity. So, yesterday we have classified the period table as block, P block, D block, and F block. This can be classified into metals, non-metals, and metalloids. Both S block, that means one is NS1 and NS2, that means lithium, beryllium, sodium, magnesium groups can be called as metals. The estimate of oxygen, fluorine, those two groups will be the totally non-metals. Totally non-metal. Of course, hydrogen we are not talking. So, inert metals anyway, inert gases are helium, neon and all. There are something in between is the metalloids also. That is, sometimes they behave as a metals, sometimes they behave as a non-metals. So, and in periodic table, if you see the group wise, so first S blocks we already told it is that metal character also will increase by increasing the downwards. Means lithium to francium, beryllium to radium. The metal character will be increasing and the its what you call reactivity also will increase. But in between transition metals are there. What about the transition metals? All the transition metals are also, all the name itself is D block elements are metals. Exception is mercury. Mercury is a, though it is called metal, it is a liquid metal, it doesn't have the normal property. This is one of the exceptions. Remember all the time, liquid metal, it will be questioned as liquid metal. Then two more exceptions also there, that is gallium and cesium. Because though they are metals and all, at root 30 degrees centigrade itself is the around 30-31 degrees centigrade itself is the gallium and cesium melting points. So these three are the exceptions in this normal metals and metalloids in the periodic table. Okay, three exceptions in this one. Then one is mainly mercury and then gallium and cesium. Their thermal conductivity will be more, their electrical conductivity will be more, their ductile and all these metal characters are listed. Then if you see the from left to right, the metal character will come down and non-metal character will go up. That is the trend of the physical property. There are so many physical properties based on this also will conclude. That is nothing but melting point, boiling point, fusion, vaporization, enthalpy, ionization potential, so many. Now we'll see some 2-3 parameters like atomic radius. Atomic radius. Atomic radius will be normally in the range of picometer. PM it will be written. PM is nothing but picometer, that means 10 to the power of minus 12 meter. Minus 12 meter, picometer. Meter, if you go down and nanometer, picometer. So this is a picometer, 10 to the power of minus 12 meter. So this is the a diatomic molecule, you can make it off it, that will be normally measured by X-ray diffraction. X-ray spectrometers it will be used for the measuring the atomic radius and X-ray methods, spectroscopic methods, X-ray diffraction methods, so many methods are there, but X-rays will be normally used for this atomic radius and all. Now, if you see interesting points, please note down some 2-3 points. If you see the lithium beryllium, there's S group lithium beryllium, and if you see first, second, third period, 7 periods we see third period. So lithium second period, lithium beryllium, boron, carbon, and all. From left to right, what will happen? Atomic radius decreases from left to right in second group or third, second period or third period. Why I will tell after 1 minute. Similarly, from top to bottom, left in the left or right, from top to bottom, it increases. Why? This also well. Now I will explain. So if you see just lithium, you take. Lithium is 3 atomic number. That means 1s2, 2s1. And if you see under the lithium, this will be the sodium will be the 11, that means 1s2, 2s2, 2p6, 3s1. That means, see, this is one, this is another one, it has jumped immediately to the third one. So there is a, but if you see lithium to beryllium, you take beryllium. Beryllium is 1s2, 2s2. So beryllium is here itself. Beryllium is adjacent to the lithium, whereas sodium is next level. So in the groups, it will go down to the next levels, whereas in the period, it will be the same shell. That is the reason that why in the same shell, the number of protons are increasing. That means thereby the nuclear charge, positive charge is increasing, but it is in the same shell, so shell is shrinking. Shell is shrinking. So radius will come down. So left to right, the atomic radius will come down because of the nuclear charge is increasing. Electrons are going in the same shell, and so radius will come down. Whereas from the left to in the left from top to bottom, though there is an increase in the nucleus charge, but it is going to the next shells. So its radius is going on increasing. So remember all the time, from left to right, atomic radius is coming down, and from top to bottom, atomic radius is increasing. This is regarding the atomic radius in group and period wise. Then comes to the, what about the ionic radius? How ionic radius is varying. Ionic radius means there is a loss of electron or gaining of electron, both are ions only, in the positive side or negative side. So if you see the cations and anions, in the cations, that means lithium is becoming lithium plus electron, lithium. So from compared to the atomic radius, lithium ion cation radius will be less, because electron has gone and positive charge is more, so it is shrinking. So ionic radius is coming down in the cation type. Okay. Similarly, anion, when it is gaining an electron, suppose chlorine, you take. Chlorine is taking electron, is a chloride ion. So it's will more. The radius will be more. So for anions, the radius will be, the ionic radius will be more. In the cations, it will be the lesser. So that will be the trend. If you see plot a graphs, suppose first atomic number and atomic radius. This is atomic number and atomic radius. You see in the lithium. So from top to bottom, it will be the left to top, from top to bottom. The radius is going. I am taking about the period left to right. So this will be going on, coming down. So if it is lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, like this. We are not talking about the zero group elements, sir. That is the 18th group. We are not talking like this. It will go down in this one. So if it is in the case of the atomic radius, in the case of the both period and group, we will say fluorine, then chlorine, bromine, and then radius is going on, then iodine, then lithium, sodium, then potassium, rubidium, cesium, like that it will be. This is atomic number and atomic radius. So there is an isoelectronic species also. That means isoelectron means same electrons will be there, but charges will be different. That will be dealt in different way. So tomorrow we will see the inner transitions, how it will behave. This thing you have to remember that cation radius will be less, anion radius will be more. From top to bottom, it will be increasing the atomic radii. From left to right, it will be the decreasing. And exceptions are in the metal ions, mercury and gallium and cesium. So thank you.